Hello everyone, welcome back to Campus Papers. In this video, we are solving IGCSE Chemistry, May-June 2024, Paper 4, Variant 2. This is Part 1, covering questions 1 to 3. Let's begin. Question 1. A list of gases is shown. Have them here. Answer the following questions about these gases. Each gas may be used once, more than once, or not at all. A. State one gas which is the main constituent of natural gas. Among these gases, the main constituent of natural gas is methane. Natural gas is mostly methane. Next question. Is responsible for both photochemical smoke and acid rain? The answer is nitrogen dioxide. Nitrogen dioxide forms nitric acid as well as acid rain and also photochemical smoke. So our answer is nitrogen dioxide. Which one is unsaturated? Unsaturated simply means it contains double bond. And here, if you look at it, propene ending with ENE is the unsaturated hydrocarbon. Therefore, our answer is going to be propene. Has monoatomic particles. That would be helium. As a member of group 8, they are monoatomic gases, so therefore the answer is helium. Reduces iron 3 oxide in a blast furnace. So this is for extraction of iron, so therefore the answer is carbon monoxide. Question B. Nitrogen dioxide and carbon monoxide are removed from a car exhaust by a catalytic converter. Write the symbol equation for this reaction. So we have nitrogen dioxide as one of our reactants. So the first thing you do, you write the formula of nitrogen dioxide, NO2, plus carbon monoxide. The formula of carbon monoxide is CO. In catalytic converter, the products are nitrogen and carbon dioxide. And that is the reason why the catalytic converter is used, is to convert carbon monoxide, which is more poisonous, to carbon dioxide, which is less poisonous. So our products are. So next is to balance the equation. Whenever you're writing the chemical equation, you need to balance it. So here we have 1 nitrogen on the reactant side. On the product side, we have 2 nitrogen. And to balance that, we add 2 here. Remember that whenever you're balancing the equation, you only add number as coefficient. You don't add number in between here, or you don't increase the number here. The only place you're allowed to add number is here as a coefficient. Okay. So adding 2 here, our nitrogen is now 2. Then our oxygen becomes 4 because 2 times 2 is 4, and then plus this oxygen becomes 5. Okay, so here we have 2 oxygen, so we need to balance it to make it the same. So how do we balance this? So add 4 here. By adding 4, the number of oxygen here becomes 8. 4 times 2 is 8. Why do we add 4 and not 2? If you add 2, it's going to be 2 times 2, 4. It's going to be less than this. We need to have a number higher than the oxygen here. So 4 is okay. We have 8. So we need to make this 8. In order to make this 8, we already have 5. So when we add 4 here, we're going to make it 8. 4 oxygen here and then 4 oxygen, making it 8. And also look at our carbon. Carbon is 4. Carbon is 4. So the equation is balanced. So this is the symbol equation for the reaction in the catalytic converter. Question 2. A list of 5 metals is shown. Copper, iron, magnesium, potassium, silicon. A. All metals form positive ions. Describe how atoms form positive ions. For the simple answer is iron forms positive ions by loss of electrons. So when they lost electron, they become positively charged. And the reason why they are positively charged is because they have more proton than neutron. Remember the theory of atomic particles. Proton is positively charged, electron is negatively charged. So when they lost electrons, for a neutral atom, the number of electrons and proton is equal. But when they lost electron, the number of proton will become more. So therefore, they become positively charged. Next, state which of the 5 metals in the list has the greatest tendency to form positive ion. In other words, which one is the most reactive? Which one will easily lose an electron? And the answer is potassium. And the reason is simple. Potassium is in group 1, and group 1 metals are the most reactive metals. Next question. Suggest one of the 5 metals in the list which is not likely to show catalytic properties. And if you look at these 5 metals, we have copper, iron, and silver. Copper, iron, and silver are transition metals. And because they are transition metals, they have tendency to act as catalysts. The metals that do not have tendency to act as catalysts are magnesium and potassium because they are not transition metal. So therefore, our answer is going to be magnesium. If you like, you can put potassium, it's still correct. Next question, state which of the 5 metals in the list is a major component of stainless steel. The answer is iron. Stainless steel is an alloy that is a mixture of metals and non-metals, and one of them is iron. Question B. A student adds a sample of a metal to an aqueous metal salt in a beaker to see if a displacement reaction takes place. Complete table 2.1 to show the color of the solution in the beaker at the start and at the end of the experiment. So that means If there is a color change, reaction took place, and if there is none, reaction did not take place. So first one, we have magnesium added to aqueous iron 3 sulfate. At the start it is green, the color at the end is going to be colorless. And the reason is because magnesium displaces iron, iron is removed from the solution. Next one is silver added to copper 2 sulfate. So the color at the start, copper 2 sulfate, the color is blue. So the color at the start is going to be, and then the color at the end is going to be blue also. And the reason why it's going to be blue is because silver cannot displace copper. Silver is less reactive than copper. Therefore, there is not going to be change. The color at the start is going to be the same as the color at the end. Question C. Most group 2 metals form a gas when placed into cold water. An alkali solution is also formed. Name the gas formed when strontium is added to cold water. The gas that is going to be released is hydrogen gas. Whenever metal reacts with water or they are placed in water, the gas that is going to be released is hydrogen gas. Name the alkaline solution formed when strontium is added to cold water. The alkali that is going to be formed, the alkali solution that is going to be formed is strontium hydroxide. Just like we have sodium hydroxide, potassium hydroxide, magnesium hydroxide, and so on and so forth. Strontium is a group 2 metal, so it also have the same characteristics. So the answer is strontium hydroxide. Next question. One group 2 metal reacts very slowly when placed in cold water. When heated, the metal reacts with steam to form a white solid. Identify this metal and name the white solid form. The metal is magnesium, and the white solid that is going to be formed is magnesium oxide. Question D. Under certain conditions, iron will react with steam to form an oxide of iron with the formula Fe3O4. Fe3O4 reacts with dilute hydrochloric acid to form a mixture of iron 2 and iron 3 salt and water. Deduce the symbol equation for the reaction between Fe3O4 and dilute hydrochloric acid. So we have the reactant plus hydrochloric acid. So remember, we are told that the product that is going to be formed is an iron 2 and iron 3 salt. So that means we are going to have iron 3 salt and iron 2 salt and then water. Okay, so when you follow the question, you'll be able to arrive at this. Next, as usual, we need to balance the equation. Now, if you look at it here, we have 3 ions, while here we have 2 ions. So how do we balance that? Balance that, we add 2 here. So we add 2 here, we have 2 ion and 1, 3, and then 3. So ion is balanced. Next is oxygen. We have 4 oxygen here, while here we have 1 oxygen only. So to balance here, we add 4. Don't forget, like I said earlier, when you're balancing equation, you already add as coefficient. You don't come and add 4 here or in between here. Only as the coefficient of the compound. So when we add 4 here, oxygen becomes 4, which is balanced. Next is hydrogen. Here 4 times 2 is 8. That means we have 8 hydrogen. Here we have 1 hydrogen. So when we add 8 here, our hydrogen becomes 8 also. So hydrogen is balanced. Next is chlorine. We have 8 chlorine on the reactant side. The product, we have 2 times 3 is 6 plus 2, that's 8. So therefore, the equation is balanced, and that is the symbol equation for the reaction between Fe3O4 and dilute hydrochloric acid to give us an iron 2 and iron 3 salt and water. Okay, so just follow the question. The reactant is given to you, this and this as the reactant, and the product is also given to you, which are iron 2, iron 3 salt, and water. Look at it, iron 3, iron 2, and then water. And then the last step is to balance your equation, and that is all. Next is question 3. The symbol equation for the industrial production of ammonia is shown. This is the symbol equation. And then we have this, very important, you take note of this. Name this industrial process. The industrial process is Haber process. State the meaning of this symbol. This simply means enthalpy change. Next, state the typical conditions and name the catalyst used in the industrial production of ammonia. So the conditions are temperature 450 degrees Celsius. Don't forget, we are asked to write the unit. Pressure 200 atm, which is atmosphere. Then the catalyst is ion. So you need to memorize this condition for Haber process and contact process, and their unit, very important. For pressure, you need to know the unit in atm and kPa. Next question. State 2 methods of increasing the rate of this reaction. So we want to increase the rate of this reaction. What do we do? So you simply increase the temperature and the pressure. When we increase temperature, particles will collide more faster, they will gain energy. Then we increase pressure, particles will be closer together, so the rate of collision, the tendency of collision increases, and therefore increasing the rate of the reaction. These are the 2 methods for increasing the rate of this reaction. E. The symbol equation for the reaction can be represented as shown in figure 3.1. This is it. Table 3.1 shows some bond energies. Use the bond energies in table 3.1 and the enthalpy change To calculate the bond energy of an nitrogen-hydrogen bond in kilojoule per mole, use the following steps. So let's follow the step. To calculate the energy needed to break bonds in the reactant. So this is our reactant. So we need to calculate the energy needed to break the bond by adding the bond energies of this and this. So look at our bond energy. Nitrogen-nitrogen triple bond is 945. So this is 945 plus hydrogen-hydrogen bond is 435. So we have 1, 2, 3 of it here. It's going to be 3 multiplied by 435. When you punch your calculator, what you are going to get is 2250 kilojoules. Okay. And next, calculate the energy released when the bonds form in the product. So this is the product. We have nitrogen-hydrogen bond, and that is what we are looking for. We are not given. But how many do we have? We have 1, 2, 3. So we have 3 here, and then we also have 1, 2, 3, 3 here. So 3 plus 3 is 6. So let's represent the nitrogen bond with NH bond. So we have 6 nitrogen-hydrogen bond. Okay. So next is to calculate the energy of the nitrogen-hydrogen bond. How do we do that? Remember the formula for calculating the enthalpy change: energy in minus energy out. That is, energy needed to break the bond, but minus energy released when the bond is formed. So in this case, it's going to be 2250 plus 6NH. This is equal to the enthalpy change here, which is minus 90. And we make this subject formula. So here it's mathematics. So this is going to be 6NH is equal to 2340. So we divide both sides by 6 so that we can get the nitrogen-hydrogen bond. When you punch your calculator, 2340 divided by 6 is going to give us 390. So therefore, the answer is 390 kilojoule per mole. F. An incomplete symbol equation for the preparation of ammonia in the laboratory is shown. This is the incomplete equation. Complete the symbol equation. So we have to complete this symbol equation. We have calcium, ammonium chloride. It was calcium chloride plus water. How do I know it is water? If you look at it, we have calcium chloride. Then we have ammonia NH3. So what we are left is it's 2 hydrogen and 1 oxygen. And then 2 hydrogen and 1 oxygen is water. Next, name this. So this is ammonium chloride. Next question. Calculate the volume of ammonia measured at room temperature and pressure, which forms when 1.12 gram of calcium oxide is heated with excess ammonium chloride. The molar mass, or if you like, the relative molecular mass of calcium oxide is given to us as 56. So here we want to calculate the volume of a gas at room temperature and pressure. Now, in order to do that, you need to remember your formula, which is volume of gas at room temperature and pressure is equal to number of moles, which is N, multiplied by 24 dm³, which is the volume of gas occupied at room temperature and pressure. Now, but if you look at here, the unit is centimeter cube, so we need to change this to centimeter cube. So therefore, this is going to be N multiplied by 24 times 1000. Change it to centimeter cube, we multiply it by 1000, which is going to give us 24,000 centimeter cube. Then we need to find the N, which is the number of moles of ammonia gas. But from the question, we are not given the mass of ammonia gas or the number of moles of ammonia gas, but we are given the mass of calcium oxide. Since we have the equation of the reaction, we can get the number of moles of calcium oxide, and then we use the mole ratio to get the number of moles of ammonia. Now, how do we do that? From here, remember the formula: number of moles is equal to mass over molar mass. The mass is 1.2 gram, and then the molar mass is 56. So this is going to be 1.2 divided by 56, which is going to give us 0.02 moles. Now, we use the equation of the reaction, that is the mole ratio, to get the number of moles of ammonia. So the mole ratio of calcium oxide to ammonia is 1:2. How do I know that? The mole ratio is the coefficient. The coefficient of calcium oxide here is 1, and that of ammonia is 2. So therefore, this is going to be 1 mole of calcium oxide will give us 2 moles of ammonia, and 0.02 moles of calcium oxide will give us unknown. So we can name it N. How do we calculate N now? Cross multiply. So therefore, N will be equal to 2 multiplied by 0.02, going to be 0.04. So therefore, N here is 0.04. And our volume, therefore, is going to be 0.04, which is the number of moles of ammonia, multiplied by 24,000. This will give us 960 centimeter cube. This brings us to the end of part 1, covering questions 1 to 3. If this video helped you, like, share, and subscribe to Campus Paper. I will see you in part 2, covering question 4 to 6.